For the final part of this lesson, we're going to look at infinite geometric series that go on forever and ever and ever. So the question is, can an infinite series have a sum? Like if you added up all the terms, not a partial sum, but added up all the terms, do they actually add up to a number, or do they just get bigger and bigger and bigger? It's basically what's called converging or diverging. So with a geometric series, do they converge so that you actually approach a number, or do they just keep getting bigger and bigger? So we're going to be real surface on this. It's real easy to tell. So if the absolute value of your common ratio is larger than 1, then your terms are just getting bigger and bigger as you go, which means there's no sum. Therefore, there's no sum. This is it's called divergent. It just keeps getting bigger. But if the absolute value of r is less than 1, like it's a fraction, like 1/2 or 1/3, that means your terms are going to keep getting smaller. And so you do have a sum. So the sum of the whole series of all the numbers together is your first term divided by 1 minus your ratio. Okay, so we're not just adding a few of the terms, we're adding up every single term in the series, in the sequence. And it's always going to be the first term divided by 1 minus r. Okay, so for example, find the sum of the infinite geometric series. So here's your series. It's 3/8 minus 3/16 plus 3/32 minus 3/64 plus ... and it just keeps going forever and ever and ever. Okay? So the first thing we have to answer is, what is r? Okay, so the way we get r is we take the second term, which is negative 3/16, and we divide by the first term, which is 3/8. Okay, that is negative 3/16 times 8/3, which that becomes negative 1/2. So we're multiplying by negative 1/2 every time. And then we just check. What we realize is we check, well, what is the absolute value of negative 1/2? Is it less than 1? Well, absolute value of negative 1/2 equals 1/2, which is less than 1. So yes, so the sum exists. And it is this formula. The sum is the first term divided by 1 minus the ratio. All right, so we got to do a little work there. That's going to be 3/8. 1 minus negative 1/2 is 1 plus 1/2, which is 3/2. So that is 3/8 times 2/3, which this ends up being 1/4. All right, last little trick here. Writing a decimal as a fraction. There's actually a shortcut, all right? So if you have one digit that repeats, then you're going to have a denominator with 1 9. This is going to make sense in a minute. 1 9. If you have two digits that repeat, then you're going to have a denominator with 2 9s. Let me write that as a word. Let me show you what I mean. Here's an example. Let's say our decimal is 0.7 repeating, which would be 0.7777 ... So notice you just have one digit that's repeating over and over again. The 7 is repeating over and over again. So the way you do this as a fraction, it's going to be the repeating digit over 9. That's what it is. In your calculator, if you did 7 divided by 9, you would get 0.7777 repeating. All right, let's look at a second example. Let's say we have 0.14. Let's try that again. 0.14. I'm going to actually give it a little bit more room. And it just keeps repeating. Notice that we have two digits that are repeating over and over and over, right? The 1 4. It's 1 4 1 4 1 4 1 4. All right, so your fraction is going to be the repeating part, which is 1/4 over 99. So 2 9s. Okay? All right, last example. Let's say we have 0.303030 ... Again, we have 2 repeating decimals, or 2 repeating digits. So the repeating digits are 30 over 99, and then we would reduce that to 10 over 33. All right, that's it for the notes. The 8.3 lesson is posted. It is not actually due until a couple of days after we get back from break. So if you don't do it over the break, that's totally fine. I hope that you have a wonderful Thanksgiving break with lots of rest. And we'll see you when you get back.